This is our 14th lesson, part 6, waves. Today our topic is about reflection of wave. What is that? Reflection of wave. Whenever a wave traveling in one direction strikes a surface, then it will reflect back, bouncing back into the same medium. We have studied this in lower classes, but we have taken light there. When the light incident on a mirror, light reflects from the surface of the mirror. That is reflection of light wave. Today we will discuss about reflection of sound waves. Reflection of sound waves. But whenever a light reflects from a surface, what happens first we will see, because we have studied that in lower classes. Then we will apply the same thing for sound waves also. So for this, what we are going to do, we are taking a surface here. Now we are taking light. We are considering light incident on this surface. Light incident on this surface like this. Light incident on this one. After incidenting on this one, the entire light will not be reflected. Some part of the light will transfer through the surface, but let us say some light is coming back. Here, if you consider the normal here, students, normal, it makes equal angle with this one, right? The angle of incidence is good angle of reflection. Is it true in case of sound wave or not? Yes. Even though we studied this for which one? Light, we can say this is correct in case of, this is alpha, this is alpha, I will take this as I, angle of incidence. And what about this angle? Angle of reflection. So here I can write I is equal to angle, I is equal to angle R in case of light waves. We studied this, but in case of sound also it is correct. But the fact is that we have to remember is some part of the light may enter into the other medium. So now we will come to the sound medium. Which medium? Sound. So now this is the surface and a sound wave is traveling here. Which wave? Sound wave is traveling here. So let us say this is the sound wave which is traveling like this. Then some part of the sound will come back into the same medium and some part of the sound may enter into the other medium. So here this is a incident wave. What is this? Incident wave. What is this? Reflected wave. This is a refracted wave. Refracted means bending of light. But here what we are going to do, I will call this as a transmitted wave. What is this? Not refracted. I will call it as transmitted wave. This is a transmitted wave. So in this case, students, in this case, what I am going to do, this is entirely a different medium, right? This is entirely a different medium. So in this different medium, this is entirely different medium. So in this medium, whether the speed is same or different? Speed will be different. So what are the changes that you can see when you are considering this sound wave which is traveling from one medium to another medium? So I call this as medium 1. What is this? This is medium 2. So what are the changes takes place when a sound wave travel or a light wave travel from one medium to another medium? That already we discussed in we discussed that, right? We have discussed that one in our school standard. Now what are the changes that will take place when the light travels from one medium to another medium, and what are the changes that takes place when sound travels from one medium to another medium? Here some part of the light is reflecting back, or some part of the wave is reflecting back. It may be sound wave or light wave, but I will just call it as wave. What is that? Just to call it as wave. So when a wave traveling from medium 1 to medium 2, 1 to 2. So what changes you can see for this wave? I am just talking about wave. I am not talking about light wave or sound wave, just wave. First, reflection. What happens we will see. And then refraction. Reflection, refraction. And here the quantity, physical quantity. So first one, reflection. If you take the physical quantity, first I will take frequency, students. What is the first one? Frequency of the wave. We studied this in this lesson only. For the wave, frequency never changes. Frequency only depends on source. Here, let us say this is the source from which this wave is starting its journey. This is the source. What is this point? Source. From the source, the wave is coming. From the source, while coming, source is emitting, let us say 100 waves per second. What is the frequency? 100 Hz. What is the frequency? 100 Hz. So here frequency is F. I will call this as Fi. What is Fi? Frequency of the incident wave. And what is this frequency of the transmitted wave? This is the frequency of the reflected wave. Frequency only depends upon the nature of the source only nature. It does not depend upon medium. So now tell me, what happens to the frequency while after reflection? Do not change. Can I say same? What happens to the frequency of the wave that is traveling through the other medium, transmitted medium? Same. So it is not changing. Frequency is not changing because frequency only depends on source. That's why frequency remains same. Number 2, speed of the wave. This we studied in school standard. Speed of the wave. Here this is medium 1. This is medium 2. Then speed compulsory changes when it travels from one medium to another medium. But in a single medium, speed never changes. Let us say I am taking this as air, students. Let us say this is some other medium. Let us say this is a glass piece or some other medium, not only glass, some other medium other than air. Let us say this is petrol or diesel. That is also okay. Then also sound can travel, and sound wave can travel through iron also. Okay. Now what happens to the speed for a reflected wave? Why it is same? Because speed depends on medium. This medium same only na. Both incident and reflected light rays are sound waves are traveling in the same medium. So what I can write here? Then what about the speed in the other medium? As medium changes, this changes. Speed changes. Now third one, wavelength, right? Wavelength. This frequency F, this speed V, this wavelength lambda. Once again I am telling, this is the same, this is same. What about the wavelength? Because we know V is equal to F lambda, correct? V is equal to F lambda. For a reflected wave, frequency not changing, speed is not changing. That means this is not changing, frequency is not changing. That means wavelength also not changing. If any one is changing, other one may change. So I can write the wavelength of the reflected wave remains same. What about this one? Because Here the frequency is constant as the speed is changed. It is constant. So can I say V directly proportional to lambda? Because it is a constant. So what we can write here? What happens to the wavelength of the transmitted wave? Changes. Increases or decreases we will see later. But first of all, we should know what are the quantities that are changing, what are the quantities that remains constant. Fourth one, angular frequency, omega. Angular, what is the formula for omega? 2 pi f. 2 pi already constant. How frequency changes, similarly omega changes, right? Now what is this? Same. So omega also same, both for reflected as well as transmitted waves, both the angular frequency remains same. It won't change. Fifth one, propagation constant, also called angular wave number, also called propagation constant, K. K students 2 pi by. Now tell me, what happens to K value when light travels from one medium to another medium or reflects back? First of all, this is 2 by constants. How lambda changes, K also changes like that. Lambda increases, K decreases. If lambda decreases, K increases. But it is similar to lambda. Actually, it is proportional, but ulta, but change. Here, wavelength same. And what about the K value for reflected wave? What happens to the K value for refraction of transmitted wave? What is this? What happens here? Changes. Lambda changing, 2 pi by lambda changes. Correct? Then next one, phase. Next one, phase. We will see how the phase changes. But here we have 2 cases to this. We have 2 cases here for phase. First one, let us say this is a rarer medium. Which medium? Rarer medium. Let us say this is a denser medium. Whenever light reflected from rarer to denser, there will be a phase change of pi, 180 degrees or pi radians. So what I am writing here, we have 2 cases, 2 possible cases here. How many cases? 2 possible cases. One is rarer to denser. Rarer to denser. Phase change is equal to how much? Pi radians or 180 degrees. Pi radians are 180 degrees. Now, if it is from denser to rarer, delta phi is 0. No change. Phase won't change. So when phase changes, when I am speaking now, this sound wave is traveling through the air. It is striking the wall, which is rarer here. Air is rarer, wall is denser. Then while coming back, phase changes by 180 degrees. I will explain in the next this one how it is changing. Suppose if I am speaking in water, I am inside water and I am speaking, the sound wave is traveling through water and coming out into air. So which is denser? Water denser. Then there is no phase change. Rarer to denser, phase changes. Denser to rarer, no change. But for refracted or transmitted one, delta phi is always 0. Now after this phase, now what happens to the amplitude of the wave we will see. Amplitude means, let us say this is the wave that is coming here, having amplitude AI. What is AI? Amplitude of the incident wave. Then the wave will come like this with a different amplitude, and it may come with a different amplitude transmitted. So now the seventh point, amplitude. here the amplitude, remember students, suppose there is no transmitted wave, there is no transmitted wave here, transmitted wave is not there. So what is the meaning of this one? There is no transmitted wave, medium 2 is present, but the transmitted wave is not there, then what happens? The complete energy will be reflected back only, complete energy of the wave will reflect back. Yesterday we studied this formula, I have given this formula. Intensity is given by 2 pi square f square a square rho v. This is the intensity of the wave. So intensity depends on what? Now here the total intensity is I. What is the total intensity here? I. Why? The complete energy is coming back. Intensity is nothing but energy per unit area per unit time R. So energy is not changing, intensity will not change. That's why this is I, this is I. Intensity is not changing, energy won't change. Intensity not changing means what the meaning of this one? The amplitude is not changing. So what is the amplitude of the reflected wave? Same as that of incident wave. When if there is no transmission, if there is no, so that's why I am writing here. If there is no transmission, there is no transmission of wave, the complete energy comes back into the same medium. So then A reflected is equal A incident, correct? A reflected is equal to A incident. So there is no change. What I write here, the amplitude won't change. But it is under condition. It is under one condition. No transmission. A reflected is equal to A incident. When? If no transmission. Suppose if transmission is there, if light is transmitting, then I cannot use that concept. That's why what I am doing here, I cannot write this and this. This is correct only if no transmission takes place. If transmission is there, then AR is not equal to AI. So for that I am giving a formula. A reflected is equal V2 minus V1 by V2 plus V1 into AI. So students, here no transmission. What is V1 and V2? This is the velocity of the wave in the second medium. This is the velocity of the wave in the first medium. V1, V2. Suppose if it is 0, no wave is entering here. V2 0. So what will get? Minus V1 by plus V1. V1 will get cancelled. A reflected is equal to minus A incident. Yaka minus. Opposite aste. Clear? Now similarly, what is A transmitted? 2V2 by V2 plus V1 into AI. These formulas are valid, useful only for advanced, JEE advanced. But just remember these formulas. Enough. Now down. Reflection of waves. In this case, students, I am taking one string. I am taking a string and it is striking a denser medium. Striking a denser medium. So after striking this denser medium, what happens we will see. So this is a wave striking here, but here we have not produced a wave. This is just a string. What is this? This is a string. This is string. So in this string, by applying some force, let us say this is a string. If you give one jerk, then a pulse will be created. What will be created? A pulse will be created. So I am creating a pulse here now. So in this region I am going to, in this region I am going to have a small pulse. So the pulse can be drawn now. Pulse can be drawn now. This is the pulse that is created in the string. Where? In the string. The pulse is created. So the pulse is traveling from where to where? Left to right. With a velocity v. So this is the pulse that is created on the string. It is moving from left to right. So while reaching this point, what is the equation of this pulse? This is wave only, a wave only. A small part of wave is called pulse. Okay. Now, what is the incident waveform? Can I write like this? yi is equal to a sin omega t minus kx. Is it correct? It's a waveform only. Now, after striking this, what is this medium? What is this medium? Denser or rarer? This is denser medium. This is denser medium. And this is a rarer medium. What is this? Rarer medium. So how the pulse is traveling? Rarer to denser or denser to rarer? Rarer to denser. Just now I gave a table. Whenever a wave traveling from rarer to denser, there will be phase change of pi or 180 degrees. 180 degrees. Students, in the previous lesson, SHM, so we have studied this. If a particle is starting from here, it's a journey and moves from A to B, what is the angle described by the radius? How much? What is the angle of radius here? How much it is? Pi by 2. When the particle reaches exactly opposite point, what is the total angle described by this one? How much? So can I say that this is pi? So what is meant by pi? Ulta. In our language, previously particle was here, now particle is point. Exactly opposite? Exactly opposite. So here the total phase change is pi. So if delta phi is equal to pi radians or 180 degrees, can I say both are in opposite phase? These two are. It is going up, students. This is going down. So both are opposite. The sense is opposite. So whenever phase is pi radians or 180, they are said to be out of phase or opposite phase. Out of phase or opposite phase. Clear, students? Out of phase or. Now tell me, here in this case what happens? It is coming like this and here it will reach clear. The same pulse will travel up to here. After striking this one, what happens to the pulse? Phase change 180. Out of phase or ulta phase. Out of phase or opposite phase. So what's the meaning of opposite phase? Tell me. Can I call it as crest? Crest will become trough. Crest will become. So here, after striking this denser medium, this will come to this position. This we call it as a reflected pulse. So what is the equation for reflected pulse? Tell me. The amplitude will be same only. The amplitude will not change. The amplitude will be same only. Amplitude will not change. Amplitude will not change. Amplitude will not change here. What changes? The amplitude will not change. But what changes? Here, amplitude remains as A, sine remains as psi, omega in reflection. See the table? Frequency not changing. Omega also not changes on reflection. So omega remains as omega time minus k. Lambda is not changing. K also remains. X ಅರ್ಥ ಆಯ್ತಾ? So this equation we can write yr is equal a sin omega t plus kx plus something is happening. This is traveling along negative x-axis, but there is a change of phase. How much? So what I am going to write here, for this I am adding pi also. I am adding. So then omega t plus kx plus here the phase change. How much? Phi. So y reflected is equal a sin omega t plus kx into 180. Sin 180 plus theta. Sin 180 plus theta. Sin theta ne. But in the third quadrant sin is negative. Minus sin theta. Omega t plus kx into minus. ಮಕ್ಕಳೇ ಅರ್ಥ ಆಗಿದೆ? sin 180 plus theta ಎಷ್ಟಮ್ಮ? sin theta, but negative. Why negative? In the third quadrant, we studied this all silver teacups. This is 90, this is 180, this is 180 plus theta. Here sin is negative. That's why sin 180 plus theta is sin theta negative. So this is incident pulse equation. This is reflected. Is it correct? Once check it. Here, if you observe this one, students, incident amplitude how much? A. What is the reflected amplitude? A only, but negative, because this is plus A. While coming back, minus A. So it will come like this only. Throughout the journey, it will come like this only. It won't go up. ಅರ್ಥ ಆಯ್ತಾ? While incident pulse, it is traveling above the string. While coming back, the amplitude will be reversed. Magnitude same. Suppose if it is 10 centimeters, this is also 10 A, but minus 10. So amplitude becomes to minus A. And equation we know. This is along positive x-axis. This is along negative x-axis. So what is happening here? Wave is traveling from where to where? Wave traveling from where to where? Rarer to denser or denser to rarer? Wave pulse traveling on a string, stretched string. Okay, we can write string. From rarer to denser. Then what are the changes? What changes? The amplitude will not change, but its direction changes. And the wave equation, this changes we know. This is when the wave pulse traveling from rarer to denser. We will see now what happens if wave pulse travels from denser to rarer. So the same thing I am drawing here, students. This is the denser medium. What is this? Denser medium. And the wave is traveling from where to where? Denser to rarer. Denser to rarer. And now I am showing the wave pulse. I am showing the wave pulse. It is traveling with the velocity v. So this is a denser medium. Which medium? And now it is traveling into rarer medium. Suppose if it is not entering into rarer medium, this is rarer medium. If it is not entering into rarer medium, there also wave pulse is not entering into denser medium. Complete reflection. What is this? Complete reflection. Here also complete reflection. It is not entering into the rarer medium. They are not entering into the denser medium. Then what happens? From denser to rarer, what is phase change? What is phase change? What is the incident wave equation? yi is equal to a sin omega t minus kx. What is the reflected wave? Now the reflected wave will come like this. Even amplitude remains same but not be inverted. Here the amplitude inverted, right? ಮೇಲಿಂದ ಕೆಳಗೆ. So here a inverted, here. Here this is a, this is also a is not inverting. Y reflected is equal a sin omega t minus k minus x. This is plus x, this is minus x. Plus phase angle. So what is y reflected? A sin omega t minus plus. That is the only difference between the incident and here a remains as a remains as a only. A remains as a. Only changes direction changes. That's why this is a minus kx. This is a plus kx. That is the only difference when the light or wave travels from wave pulse traveling from where to where? Denser to rarer. So what is not changing here? That we have to remember. Which is not changing? Here amplitude inverted, and the minus kx will become plus kx because previous it is moving along positive x-axis, now negative x-axis. Here amplitude is also not inverted but direction changes. This is clear. What happens to the displacement of the wave after transmitting into the other medium? We will see. So first one here, this is the pulse traveling like this and it is produced on a string. This is a pulse produced on a string. Later friends, here there is another string having more thickness, and this is fixed between two rigid supports. That means I have taken two strings here. One is a lighter string, the second one is a thicker one. Their radius are different, their masses are different. Can I say this is a rarer string, denser string? Both are made of same material only, but there is a difference here. So here, when it is traveling with a velocity v, and the amplitude of this one is, let us say, capital A. Now this pulse is traveling like this. After striking this one, what happens? Some energy will be transferred into this one, and some will come back. So from where to where the pulse is traveling here? Rarer to denser or denser to rarer? Rarer to? So here, wave on a string, moving or traveling from rarer to denser. Rarer to denser. This rarer, this denser. Now, what is the equation for displacement of the incident wave? Tell me. A sin omega 1t minus kx, k1x. What about the transmitted pulse? Yes, tell me. Why transmitted? This is A I only. This will become A t sin, whether omega changes or not, from one medium to another medium. See the table. Frequency never changes. So omega also never changes. Omega 2 pi f. So f is not changing means omega also not. So if it is omega 1, can I write this as omega 1 t only minus k2 y k2. This is different from this one. This row or string is different from this one. So the string has changed. Whenever medium changes, speed changes, wavelength changes. Speed changes. So that's like K also. But it is moving in the same direction or different direction? That is along positive x-axis, this is along positive x-axis. Then what about Y? Reflected. Why? This is other meaning. Why? Reflected. So what you can write? A reflected sine. Omega changes or not? For reflection there is no change in omega. Omega t minus k2 minus x plus 5 y5 rarer to denser phase change will be 180 degrees or 5 radians. So how this formula will change? yr a minus ar the sine of what will be plus sine 180 plus theta minus ar sine omega 1t minus plus k2x. So what are the changes we will see from the incident to reflected, incident to transmitted? Only we will discuss the changes that are occurred here. First, this is our original equation of the incident wave. From there to transmitted, what are the changes? Whether this is changed or not. I gave a formula for finding transmitted wave. What is it? A transmitted is equal to V2 by V2 plus V1 into A. Right. As the medium changes, velocity changes. The velocity here is V1, here velocity will be V2, but this velocity is V1. Incident reflected waves will have same velocity. Transmitted wave will have different velocity. So based on that one, this AT change. One more change. What is the one more change? Omega 1 is not changing, but the propagation constant depends on medium. It depends on that's why this also changes. Now you come to the reflected wave. What are the changes from AI to AR? What is AR, students? Amplitude of the reflected wave V2 minus V1 by V2 plus V1 into AI. So compulsory V1, V2 are different. Even though we are talking about the incident and the reflected, we need velocity of the medium, second medium also to find out this A reflected. So it is changing. Then omega 1 to omega 1t plus will become this K1 remains as K1 only because this is for reflected. This is medium 1, this is also medium 1. In the same medium, lambda will not change. K also will not change. So what I have write here? K2 or K1? K. This is K1 only. So this is a story when the pulse or wave on a string is moving from rarer to denser. Now, from denser to rarer. So, I need to take one thick one. This is a denser row, denser string, followed by a thin one. So, what is this velocity? Here velocity I will take it as V, which is V1 is equal to V. And this is the joint, boundary of these two strings. Now what is incident wave? Tell me. What is the displacement of the incident wave? How much? Tell me. A sine omega 1t minus k1x. What is this? Displacement of the incident wave. Then this one will reflect back with the phase change or without phase change, because this is called denser to rarer. phase change will be 0. So what we can write now? Y reflected. How much it is? Is it same or different? We cannot. It all depends upon this velocities. So I cannot write A here. If there is no transmission, if entire light is coming back, previous one I told you, complete reflection. For complete reflection, this will not change. But here, sun is traveling like this. Here it is coming back. How it is comes back? Same amplitude, because density rarer, no inversion. So I can write A reflected sine omega 1t plus k1x for reflector, this one, it is moving in this direction, right? Velocity. So k1x omega 1t, this will not change. Only change is transmitted is different amplitude, incident is different amplitude, reflection is different amplitude. Now I will talk about this one. What is that? Transmitted wave. So what is the displacement of the transmitted wave? A transmitted. How to find A transmitted? We have this formula. How to find A reflected? We have this formula. Into sine. Whether from 1 medium to the medium omega changes or not. No change in frequency. No change in omega. So this is omega 1t only. Even in the second medium it remains as omega 1 minus same direction or different direction? This is same. K changes or not? Another medium K changes. That's it. Solve a problem based on the reflection of waves. A wave represented by y is equal 10 sine pi t minus 2x incident pi t minus 2x incident on a surface. Find displacement of reflected wave, displacement of reflected wave if surface is denser, surface is rarer. Surface is denser or surface is rarer? So first denser. Students, this is the string, this is the denser. Let us say denser means let us say wall. A string connected to a wall and a pulse is created here. What is the displacement of the incident pulse? 10 sine pi t minus 2x, and even that is not given in a question. All this data is in SI units. Which units? SI units. So this is the incident wave pulse. So this is our pulse that is traveling here. From wall, nothing will enter into a wall. The wave pulse which is produced on the string will strike the wall and comes back. No transmission. It is not given in the question, but we can say there is no transmission. So here, no transmission. That means what is A transmitted? Can I say 0? What is the amplitude of the wave which is transmitting through the wall? 0. And the wave will not enter into wall. Only it is reflecting here and coming back. So what is the reflected wave form? 10 sine pi t minus 2 into minus, this is about plus x-axis, this is about plus 5 pi. So this is y r is equal 10 sine pi t plus 2x plus pi. What is sine? 180 plus theta minus sine theta. So this will become minus 10 sine pi t plus 2x. This is y reflected. Then what is y transmitted in this problem? It is not asked. Even if you want to write y transmitted, no transmission. So y transmission is equal A transmission something. A transmission itself is 0. So there is no equation. Is it clear? When it is correct, if it is a incident on a denser medium. Incident on a denser medium. Now same thing, let us say same string, same pulse. The string is connected to a ring. String is connected to a ring. The string is connected to wall and a pulse is created. But here string connected to a ring. Now the ring is passing through a rod. This is the rod. This is the rod. Clear, students? Understood? Understood? What is happened? What happened here? This is a rod. On the rod we have kept one ring. Rod kept on ring. This is the rod. The ring is placed. For the ring we are connecting a string. So now when the pulse is created, now pulse is traveling like this with a velocity v. Now here when this pulse comes here, it is striking the hard surface. But here this is called free end. What is this? Free end. So denser to rarer. We can check. Here there is no phase change. So what is the phase change here? Because this is a free end. This is free end. Then what is the incident wave equation? 10 sine pi t minus 2x. So what is the reflected wave pulse for this one? 10 remains as 10. No transmission. For the entire problem there is no transmission. That's why if incident amplitude is A, reflected amplitude is also A. Sine pi t plus 2x. There it was minus 10 plus 2x. Here plus 10 plus 2x. Not done.